In this section, we'll talk about the future of Ethereum, right? So, when I talk about future of Ethereum, I am meaning the Ethereum 2.0 that's currently in work in progress, right? So, Ethereum 2.0 is introduced to solve many problems that exist with Ethereum 1.0, right? Most important of that is the scalability problem, which means transaction throughput. We have spoken about it a lot of times that public blockchains do not have a lot of transactions per second, right? Ethereum can now do 15 to 20 transactions per second, which is nowhere near the traditional systems, right? Also, they are talking about interoperability. Imagine when you have millions of bitcoins also, right? If you're a millionaire in Bitcoin network, but if you want to buy a crypto kitty in Ethereum, right, you will not be able to do that now, right? You have to be able to go to an exchange, convert your Bitcoin into Ether. Only then you can spend that Ether into this Ether, right? Now, from a geographical boundary of traditional currencies, fiat currencies, we have moved into a technological boundary, right? Ether is a separate currency, cryptocurrency, that exists within the Ethereum world, and Bitcoin is existing within the Bitcoin world. They cannot talk to each other now, right? So, interoperability between blockchains is something that's being researched upon at this point in time, right? So, solving these problems is the motto of this Ethereum 2.0 that is planned to come out in the year 2021. Okay. So, some of the important concepts that is being implemented into this blockchain 2.0 is that sharding and proof of stake, right? So, what is this sharding concept? Sharding is a database concept. Okay. So, what we are saying is sharding is introduced to implement parallel processing. Okay. So, to solve the problem of scalability, right? If one full blockchain, yeah, with let's say 1000 nodes are there, okay, gets 15 transactions per second, that's what it can do, right? And if you consider the concept of a blockchain, how it works and all the 1000 nodes are working on a single task, right? Single block verification, validation, mining, and all of that happens with all the 1000 nodes, which means if there are 1000 nodes or 10,000 nodes, there is a 10 times increase in the nodes, but the number of transactions is not going to increase because all the 10,000 nodes is going to do the same thing, and it is the same case if it increases to another 10 times to 100k nodes also, right? So that is the concept of how the blockchain is currently working in. And what this sharding says is, I'll split this into multiple shards. Let's say this is the parent shard, okay? And there is the first shard, shard number 1, second shard, shard number 2, third shard, shard number 3, right? And each of this is a separate blockchain by itself. Separate blockchain. Now let's say this entire 1000 node block is there, right? Blockchain is being split into, let's say this is 100 GB, okay? Is being split into 10 GB shards, right? 10 GB shards, the size of the blockchain we are talking about, right? And this 1000 nodes go as 100 nodes here, 100 nodes here, 100 nodes here. Now what can happen is all of these shards together form the blockchain. So this is the parent shard, which is also called as a blockchain, right? Now if a transaction comes in inside shard 1, one of these 100 nodes is doing a transaction, so that it comes into shard 1, so this will process that. The second transaction comes inside this shard, this will process that. In this shard it will process that also. So just like that, if you split a blockchain into 10 different shards, right, 15 transactions per second will easily go to 150 transactions per second. Why is that? So you have split it, and hence these shards are working on parallel computation, correct? Parallelly they are processing the transaction, unlike previously, okay? So that's the concept of sharding. Of course, sharding also has some practical issues while implementation. Something like how does these two shards talk to each other? That is called as inter-shard communication, okay? Inter-shard communication is a huge problem when it comes to this, right? So multiple issues, and it has the problem of 51% attack also, right? So if you want to do a 51% attack on the entire blockchain, you need a lot of hardware to do it. But if you're targeting only shard number 2, let's say, it becomes a bit easier, right? You have to get 50 systems computation power only, right? So that's the reason 51% attack also is easier in this sharding, etc. So that is how sharding can be implemented, and these are the problems that are being researched upon, worked upon by Ethereum 2.0 and various other blockchains. Okay, so first one, sharding, we have seen. Second one, proof of stake. We have looked at proof of stake, how it works. Basically, proof of stake is a situation where the validators stake their coins, right? Which means the reward that they get is the actual cryptocurrency, the block reward, and the penalty is this staked coins itself. If they submit a tampered block or a tampered transaction, right, the blockchain is going to find it out and stash their stack. Okay, so whatever you have given as money will be stashed. So proof of stake is better than proof of work, they say, right? Because proof of work is energy consumption is very high and things like that, right? However, proof of stake also has some problems, right? Problems like nothing at stake, etc., right? Nothing at stake means forming a temporary fork in proof of stake is very easy. Okay, so if imagine you have a blockchain like this, if you're doing proof of work, right, the same miner finding these two is very rare, right? Very rare, because the same miner, let's say I am one miner, I create one block, immediately I get another block also to form this, that I cannot do because I won't want to do it. Spending so much electricity to create a temporary fork is not necessary, right? Not practical. Yeah, but in proof of stake, right, I am the validator for this particular slot. Okay, in this slot I can create how many ever blocks I want, and I am not spending electricity at all, correct? So I have nothing at stake in this kind of a situation, and hence temporary forks are very easy in proof of stake. So these are some problems which needs to be taken care of if a blockchain says it is going to implement proof of stake into its system. Okay, for example, proof of stake is called as Casper protocol in Ethereum 2.0. Ethereum 2.0. Proof of stake is called as Ouroboros. Ouroboros in Cardano, right? Cardano blockchain is also a very sophisticated, advanced blockchain. So they call the proof of stake Ouroboros. They have taken this concept of proof of stake and customized it according to their blockchain. Okay, so Casper protocol, Ouroboros, both are expected in the year 2021. Okay, so we can expect a lot of changes that are happening in the blockchain world in the next year, right? And you keep updating yourself with the latest changes that are happening, and I'll also let you know about the changes, right? So that is about the future of Ethereum and what we can expect in 2021, right? Keep a close eye on Ethereum 2.0 because it might come anytime now, right? See you in the next video.